Now, destructive interference, right, is quite the opposite of constructive interference. So if I go back to our first model diagram here, let's say I have one wave like this, and it has a positive amplitude of, let's say, 3. Okay, and then moving in the opposite direction is a wave, or from the opposite direction. So let's say it goes like this. And that one has the reverse amplitude of about 2. While they would actually cancel each other out, the amplitude here, because you can think about this like a negative 2, would be 3 minus 2. And that would equal 1. And so the final interference pattern would look like that. It would be 1, which would be the difference between 3 and 2. Okay? Now, if I were to go back to the original diagram here, the other version, where would I expect to see destructive interference? Because there is both destructive and constructive interference often when we have cases of 2-point sources. Well, let's say I go a little bit off. Let's say I go here. And if I'm focused just on the purple line, you see here, you got the crests, right, of the red source that is actually coming together with the troughs of the blue source. So the red doesn't meet the blue along the purple line. If I look at this area over here, right? So this would be destructive because, yeah, the crests are meeting up with the troughs. And so you're looking at points where the crests would get canceled out by the troughs, and your overall amplitudes, just for a second, would appear to decrease at the time. Now, for all of these scenarios, one thing that I kind of want you to remember is that, let's say this is a boundary, right? So it's like a wall or a mirror. So we can just call this a boundary. And let's say we're shooting light waves. So I give more than, one wave pulse. So here's 1, here's 2, here's 3, right? And actually, let's cut it down to 2. Okay. And you got a certain distance, and then another one here. Okay. So once I have my wave pulses, okay, they're both traveling this way. Once they hit the boundary, the wave pulses inverse. Oops. I'm going to write this here. So when I write wave pulses inverse after they hit a boundary. And so what that ends up looking like is, you see this wave here. So let's say we're going to call this wave A, or so pulse A, and pulse B. Okay. Pulse B, once it hits the boundary and it bounces back, it's actually going to flip upside down like that. And this is going to be pulse B. A is going to do the same thing. So every time a wave hits a boundary, it's going to change directions and then inverse. And what happens then is probably around here, because pulse B has inversed, right before pulse A hits the boundary, there's probably going to be, destructive interference at this point. Due to the inversing of B, while A is likely still over here. So this would be like your A portion, right? And so together, and I'm going to try to make this a little bit more pronounced. Together, you know, they'd probably make something like that around here. But it only happens for a minute, and once that part is gone, okay, once they both continue moving in their respective directions, then that interference is gone. And so long story short, when there's destructive interference between 2 point sources of that are generating waves, your amplitudes are going to momentarily decrease as they cross each other. Then, of course, they keep moving and things go back to normal. And so you would subtract amplitudes. And for constructive interference, your amplitudes will momentarily increase as they go past each other. And so you would add the amplitudes. And so if we're thinking about, let's say, sound waves, okay, this is what you would hear. So let's say I got sound coming from 2 point sources. Okay, so let's say I got sound wave 1. So sound purple and sound blue. Okay, and then blue propagates waves. And then purple propagates waves. Okay, the part where they cross, the constructive interference. So I'll just go like this. Constructive interference. Sound would get louder. So you know sometimes when you plug the microphone into the wrong part of the speaker and it makes a really loud sound that rings everybody's ears in the room? Yeah, that's because you got some constructive interference here. And the other portions, right, so where there's, you know, like this area here, where there are crests that meet with troughs, okay, then you would have destructive, and so your sound would go out. Okay, so sound goes out. And so one more time here, if we were to, let's say, you got a wave going this way, that's 3. And another wave going this way at 1. Okay, at about here, right? Sorry, at about here, you would have destructive interference. Okay, and your final amplitude, right, probably would be about, you go 3 minus 1, would be about 2. Okay, and that's from 3 minus 1.